Write down heading as indices and logarithms. Indices and logarithms, right? Okay, people, now under these indices and logarithms, you have learned these things in your OL, but we are going to study that again, right? Yeah, you know, when we write people here, 2 and here 3, this 2 is called as the base, and this 3 is called as the index. Or sometimes people, this is called as the power, right? And sometimes it's called as the exponent. Okay. Then the meaning of this 2 to the power 3, people, you know, this base should be written 3 times and multiply them. That's the meaning, right? This 3, the power says this base should be written this number of times on the right hand, multiply them. That's the meaning. Then really, you know, 2 into 2 into 2 is 8. Okay. So based on this pattern, people, we learn some laws called as index laws. The first index law, people, then I can explain this way. I'm going to take this 2 to the power 3 and I'm going to multiply that by 2 to the power 2, like this. Okay. Then if I write this 2 to the power 3, it is really 2 into 2 into 2. This 2 squared I can write 2 into 2. Then people, here, you know, this 2 repeats 5 times, and according to this notation, I can write, since here we have 2 5 times repeating, I can write this as 2 to the power 5 like this. Then the left hand side, we have 2 to the power 3 into 2 to the power 2. That is equal to this. Then here we form a law. How? This way, the bases here are the same, equal. And now there's a multiplication between them. Then the answer we obtain how? Adding these powers or the exponents or the indices subject to same base. And 3 plus 2 is 5, 2 to the power 5. So that is the first index law, people, you learned in your OLs. Understood? So therefore, the first index law, I can write what, people? A to the power m multiplied by a to the power n. How to take the answer? This is really a to the power m plus n. This is really a to the power m plus n. So therefore, remember the rule like this. When the bases are equal and when they are multiplied, the exponents we add, the powers we add. The powers we add. That is the first index law. Okay. People then will write a small note regarding this, right? Yeah. Then write down indices and logarithms, the heading, and write down its subheading like this: laws of indices. Right? Laws of indices. Laws of indices, right? Okay. Right, laws of indices. People first will write there as a note before going to the laws, note. Under the note, write down, consider a to the power x. Consider a to the power x. People, this a to the power x, this a is called as what, people? Base. This x is called as what, people? That 3 names, right? What? Sometimes we use the word power and index, or sometimes exponent. Exponent. Okay, right. Now, the meaning of this a to the power x is what, people? A to the power x means this a must be written, people, how many times? Right, x times. Since we don't know the value of x exactly, right? To denote that, we put some dots like this, and finally we write 1a. Now, there should be how many simple letters? Should be simple x. Then we write here x times. X times, right? This a should appear on the right hand side, simple x times. Okay. For example, I can write like this. If I write 2 to the power 3, 2 to the power 3 is nothing but, people, 2 into 2 into 2. And number 2, when we consider, you know this already, people, though we write this one, but never mind, we'll write down them to remind the things we learned. 2 to the power 3 means this 2 must be written 3 times. 5 to the power 2, 5 by 5 must be written 2 times. So therefore, when I simplify, this is 8, this is really 25. This is how we just take them, right? Okay, I will take down that, people. Right. Right. Now, people, under laws of indices, the first law now we are going to write. The first law we are going to write. Okay. First law. Number 1. Right. This is a note, people. Now, first law we are going to write. Okay. It is this a to the power m into a to the power n is equal to a to the power m plus n. People, here, rather than a proof, just verification, we can do the truth about this, right? People, proof and verification, when we say true means, people, subject to a certain mathematical laws, we step by step develop to get the final answer. People, verification is a little bit different from that. Verification means we consider certain situation, and by the situation we show this is correct. So therefore, in this case, I introduce this proof of this a to the power m into a to the power n is equal to a to the power m plus n. This left hand side is equal to right hand side, right? I am going to verify this truth of this, right? So therefore, we can do this verification like this, right? Of the truth of this, right? How, people? A to the power m multiplied by a to the power n, according to this notation, a to the power m means this simple a we must write, people, how many times? Here we have m times, right? Right. And this a to the power n we have, all right, simple n times. Okay. Then here we have simple m times the simple a. Here we have simple in times this simple lim. Then altogether, how many simple A letters available there, people? Here m, here in, m plus n. Then according to this notation, if we have on the right hand side simple m plus n number of simple A, according to this notation, this number of simple A letters only here we have. Then here, the right hand side, we have what, people? Here simple m number of simple A letters, here simple n number of simple A letters. Then total m plus n number of simple letters should be on the right hand side. It is written, people, how? According to this notation, a to the power n plus n. Understand? So therefore, the left hand side product is equal to this a to the power n plus n. So this is the verification of the truth of the first index law. When the bases are equal and when they are multiplied, the exponents we have to add. Understand? So I think you have done this in your oils. Never mind. Our first part, of course, from the starting from the oil knowledge to develop until the end of the ale, but syllabus, right? Okay, that is first one. People, second one, second index law. Second index law we can come to, right? First one can verify like this. Okay, people, second one is this. Now, when we divide something like this, for instance, consider this one. Now, I am going to divide 2 to the power 5. I am going to divide by 2 to the power 2. Then I can write, people, here. This 2 to the power 5, I can write 2 into 2 into 2. 5 times we must write this. And denominator this way. Right? Then, you know, this 2 and this 2 we can cancel down. This 2 and this 2 we can cancel down. Then 1 into 1 is 1. That 1 and this thing, when you multiply, people, you know, when you multiply any number by 1, that number won't change. For instance, 10, when you multiply by 1, does it change? No. So therefore, here 2, 2, 2 multiplied by 1 into 1, 1 doesn't change this answer. 2, 2, 2. 1 and 1, 1. People, when we divide something by 1, again that number won't change. The same thing coming. Then here this 2 repeats 3 times. So therefore, this you can write as a power 2 to the power 3. This way we can simplify this. Okay. So then in the left hand side, what do we have, people? 2 to the power 5 numerator, 2 to the power 2 denominator. So for this, the answer on the right hand side, we have 2 to the power 3. We have 2 to the power 3. Let's see how to take this power 3. People, this power 3 we get from this numerator power, we subtract this denominator power. 5 minus 2, we get this 3. So therefore, we get the second index law like this. Then what is second index law? Second index law, people, a to the power m here we have, divided by a to the power n here we have. If bases are the same, this time the two numbers being divided, then the answer is obtained, people. How? A to the power numerator index minus denominator index n minus c. That is the second index law. Understood? Right? Then shall we write down the second index law? Right. Write down number 2, second index law. Number 2 we write. Second index law we can write, people. Number 2, a to the power m divided by a to the power n is equal to a to the power m minus c. Numerator index minus denominator index, right? Okay. Right now, we can verify this too. We can write this verification. All right, I am going to do this verification like this. A to the power m divided by a to the power n. Then I can write this a to the power m people. All right, so then the power is m, no? Then the simple a letter I must write how many times, people? Right? Simple m times. Right? Simple m times. And the denominator I must write simple n times. Here, n times. Here, m times. People, now here we put some dots because we can't exactly write this because of this m we don't know. So putting some dots here, we mention here in this among the dots some simple a letters available. That's how we give this, because we don't know exact value of m. Therefore, we can't write completely the number of simple a letters to be written there. Right. So therefore, we can now do it like this. This a we can cancel down with this a. This a also we can cancel. This a also we can cancel. That now you might think like that in the middle here and here all cancel. Not all cancel, people. Here I am going to assume simple a letters, this simple m greater than simple n. Simple m, this one greater than simple n. Then numerator we have how many simple a letters? Simple a number of simple letters there. Here simple n number of simple letters. Since simple n smaller than simple m, all the simple a letters will cancel with simple n number of simple a letters at the numerator. Then the rest will be remaining there. Okay, rest will be remaining. For this, I am going to write another few a's here, right? Okay, then there also I can put, if necessary, this another dots. Then we can say this a and this a now cancelling, right? Another sum is here we have. Now you can very clearly, I write that also here. Better to write this one for more, right? Yeah, this way. Now from here to here, n a terms cancelled out of this m. Out of m, if n terms cancelled, what is remaining? M minus n. Then here we should have that m minus n number of simple a letters, right? So then this is now m minus n times, right? This a appears there, what, people? M minus n times. Then the right hand side remaining m minus n number of simple a letters. That's product, no? We can write it how, people? Since there are simple a repeating m minus n times, this is the power m minus n. Then we can write this as how a to the power m divided by a to the power n. This is how, people, we verify that situation. Okay, right. Right now, yeah, try to understand this, people. Okay, now, dear students, Right. Right, people, this is the second one. Second law. Right, no? Yes. Now let's see, people, the third law. Number 3. Number 3, suppose here, third law, you know this too. We have a to the power m. Whole thing to the power n here we have. You know how to simplify this? How to simplify this? Yeah, how to take the answer, people? We multiply this inner power with the outer power to get the answer. A to the power mn like this. Right, this also we can very easily verify. How? Right, this way. I'll take a certain small example that you can very easily think about. Right? Yeah, think like this, people. I'm going to take 2 to the power 3, that to the power 2. Yeah. Now for a while, assume this as your capital X. Assume this 2 to the power 3 as capital X. Then really here x squared only here we have. You know, if this is x, since here we have x squared, how to write x multiplied by x? But what is our x? 2 to the power 3. Therefore, this should be 2 to the power 3. This should also be 2 to the power 3. Understood? Right. Now, people, here the base 2, they are multiplied. Then we can apply first index law to take this answer. What's that, people? What's that? That is really when the bases are equal, the powers we can add. Then here 2 to the power 3 plus 3. Okay. 2 to the power 3 plus 3. People adding 3 2 times. Here. Adding 3 2 times. Adding 3 3 times. Adding 3 4 times. Here, when you add 3 2 times, this answer you can take multiplying 3 by number of 3's here. There are 2 3's, no, this way. Here, 3 3 3. How take this, people? 3 we multiplied number of 3's 3 here. We get here 3 added 4 times. 3 we multiply number of 3's 4. Like that, people, I can write this how 2, this 3 and 3, I can write 2 into 3. This 2 into 3 mean, people, you can very clearly understand. Here, when you multiply this and this outer 2 only, here we get here 3 into 2. Understood? Using that, we can say here a to the power m and whole to the power n. We can write how a to the power mn product like this. Understood? Okay. Now let's see how to verify this. Right. Write the verification. Okay. Right. Now we can write a to the power m to the power n. This a to the power m should repeat how many times? N times. And then we write a to the power m, another a to the power m, another a to the power n, and this say, people, a to the power m. Here we should have this simple n times. Right. Now we can apply to this right hand side the first index law. To the right hand side, the first index law. First index law says when the bases are the same and when they are multiplied, the powers must be added. That's what it says. Right. So then we can write this as how a to the power this m plus m plus m plus so on m. All right. Here, how many simple m letters in this sum we have? N times. This is n times. N times. Simple m, when we add n times, the answer can easily be obtained multiplying m by n. That's will known thing. Algebraic result, right? Yeah. So therefore, this is e to the power mn. Right now, this sum is right. M repeats n times in the sum. No, multiply this m by n. Right. So therefore, this is how we just verify that. Right now. The m, right? Yes. Right. That is number 3. We'll see people fourth one. Fourth one. Fourth one is this. Suppose we have a product here, AB. That to the power n here we have. Within bracket we have AB. AB product. That to the power n. Now this you can write, people, taking the power n of this both A and B like this. AN into B like this. Both this A and B should be taken to this power n. A to the power n, B to the power n, like that. Understood? Okay. How to verify this now? Yeah. People, can you think to do this? Shall I give 2-3 minutes? Just think and take. Right? See here. Okay. Then this is how I am going to verify it. People asked before. I am going to assume this AB as single letter capital X. A is a number, B is a number. When A and B are multiplied, we get another number as its answer. That I am going to assume as capital X. Okay. Then here we have capital X to the power n. That means this capital X we must write on the right hand side n times. That means this AB product we must write n times. Correct? No? Like this. AB multiplied by AB multiplied by AB multiplied by this AB. Right, here we have n times. Right. Then from each term, this simple A I write. Taking from each term, simple A I write together. This A right, we write this A here, this A here, and this A here. Since there are simple n number of AB terms here, and when we take simple A from each, finally we will get in the line simple n number of simple A letters. Okay, right. A here, A here, A here, and so on up to A here. Right. Then all A letters I took together. And this second B letter I take separately together like this. Since we have here simple n number of AB letters here, when you take B from each, in the second bracket, we get simple n number of simple B letters there. Here simple n times, here n times. Right. Here A to the power n multiplied by B to the power n. No? Why? Simple A people repeats n times. No, then that is written as how A to the power n. Okay. There B to the power n. So this multiplication sign, we can write this product without multiplication sign. Right. So this is how we get that. Okay. A B to the power n. Right, this way. This is how we verify that. Number 4. Right. People, number 5 is the next one. Number 5 is the next. Number 5 is this. Here we have a product of A and B, no? Number 5, inside the bracket, we get A upon B, A by B, right? A by B to the power n. People, now, what is here the simplification? This time, both this A and B should be taken to the power n. To write how? A to the power n and divided by B to the power n. This way. This way. Right. Yeah, I think this time, with the help of this, I think you can verify this. Truth of this, you can verify. I think now you can do this. Do this verification, therefore. Do this verification. Let's see, people. They also A upon B to the power n, no? Right. So then we'll assume this A upon B as single capital X. Since the power is n there, the capital X should write on the right simple n times. It means A upon B terms we must write simple n times on the right. Right, like this. A upon B, A upon B, A upon B, and so on. A upon B, right? N times here. Then people, here we have product of fractions, no? Product of fractions, right? Product of fractions. You know, when you multiply 2 fractions, people, like this, or 3 fractions, suppose. You know how to multiply them. These numerators we multiply together. Denominators we multiply together. That is how we multiply the fractions. Then using that, people, I can multiply all these numerators. What do you get there? A into A into A into A, like this. How many simple A letters should appear here, people? N. Then B into B into B into B. Here n times. They also n times. How to write this then? A to the power n, this B to the power n. Then you can see the truth of that. A upon B to the power n is equal to this answer. This is how we just verify that. Right. Right. Number 6. Right, people, number 6. Number 6 is this. A to the power 0 equal to 1. A to the power 0 equal to 1, people. But remember, A to the power 0 equals 1 valid when the simple a is not equal to 0. Therefore, we have to mention that within bracket like this, a not equal to 0. Right? A not equal to 0, it is compulsory there. The reason is, people, one occasion this a becomes 0, we get 0 to the power 0, no. This 0 to the power 0, people, undefined form. It has no meaning. In mathematics, we, of course, categorize them as undefined numbers, undefined forms. Nearly there are 9 undefined forms in mathematics. So those forms, people, have no real values, or nobody can say their value, or no idea about them. They are called as undefined forms. Sometimes called as meaningless. No meaning. Understood? So therefore, if we write a certain meaningless form there, that is not, of course, good thing to us, because now that has no meaning, but we express that. So therefore, to give a meaningful statement here, a to the power 0 equals 1, right? Meantime, within bracket, you must write a not equal to 0. Roughly, if I explain some meaningless forms, people, right? This is one meaningless form. And you know, infinity. Infinity also, people, we say meaningless. Infinity mean, you know, when we consider number line, you have learned about number line, no? On the number line, exactly midway, we have 0. When we go to write from this 0, people, the numbers are increasing through positive values. You know, people, when we draw the number line, we put arrow here, and to this end also we put arrow here. This arrow says, people, right? Arrow says, people, this comes to right, but it has no end. It has no end. From this end also, people, it comes to left, but it has no end. So in this way, people, when we draw a straight line, really, we can't find the ending points of the straight line on the right and left both. We can't find. Sometimes when you draw the straight line on your page book, once the page ends, of course, we will stop there. But people, we can furthermore, if necessary, produce it. Okay. So then the infinity means, people, where the right end available on the line, that right end is called as a positive infinity. The left end is called as, people, negative infinity. Infinity mark is this, the notation symbol. Then this plus infinity and minus infinity, if somebody tries to find by drawing this, extending this line indefinite, people, nobody can find the ending points. Therefore, we say this plus infinity and minus infinity also meaningless, undefined. Such values never exist. Okay. And the other one, people, infinity, when we divide by infinity, that also we consider as undefined form. Infinity minus infinity, we define as undefined form. 0 divided by 0, we define as, people, undefined form. Understand? Okay. Let's get some more forms available. Infinity to the power infinity, 0 into infinity, 1 to the power infinity, so on, people. They are considered as undefined forms. Especially, people, in our ALs, we discuss calculus. Under this calculus, we discuss some questions. Some occasions, their answers are coming one of these 3. Okay, then we reject those answers saying they are undefined, and we go for some other alternative method. We find their exact possible answers. So therefore, these are really, we are going to discuss in the future in the pure maths under calculus, right? Undefined forms. Okay, right. This is just to your knowledge. Okay, so now let's see how to prove this, people. Okay, right. So this can be proved like this. The verification we can do like this. The verification we can do, right? Okay. Yeah. I'm going to people take this way. I'm going to take a to the power n divided by a to the power n. Right. Then this a to the power n I am going to write how a simple a should be written how many times, people? N times. N times, right? This a into a into a into this a again n times. Right. Now you know in the left hand side, the base here a at the numerator, base here a at the denominator, bases are equal. Then by using the second index laws, when two numbers divided having the same base, we know how to simplify. We simplify how? Subtracting this denominator power from numerator. Understood? That is how we prove that or take the answer. So then once I apply that here, people, to left hand side we get n minus n. This n should be subtracted from this. Right hand side, the simplification can be done like this, people. This a with this a you can cancel, then we get 1 and 1 here. This a, 1 and 1 here. This a, 1 and 1 here. Like that, first a get cancelled like this. And finally, the last a also get cancelled like this. Okay. Then numerator we have, people, this 1 multiplied by n times. 1 into 1 into 1 into 1. People, when we multiply 1 any number of times, answer is, people, what? Answer is 1. Denominator also same, 1. Then numerator 1, denominator 1. 1 divided by 1 is 1. So this is 1 there. Okay. Now n minus n going to be, people, what? 0. This is how we simply prove e to the power 0 equals 1. Proof means simply verify this. E to the power 0 equals 1. Understood? Right. 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 So the number 7 is the next. Number 7. Number 7 is the next, people. Number 7. Number 7 is this. We have a to the power n here. Right. People, when I write a to the power n here, right? When we write any number, people, any number is a fraction. When you consider any number, consider 10. 10, people, 10 is really 10 divided by 1. 10 is really 10 divided by 1. Denominator is 1 of this 10. Okay. So that is why we say any real number, when we consider, it's a fraction. Right. Now this a to the power n also, when I write, really, this a to the power n means a to the power n divided by 1. A to the power n divided by 1. People, the next law, you know already this. This says this a to the power n, at the moment it is at the numerator, no. You can bring this to denominator here. Then this law says the sign of this power take opposite, gets opposite. Once I bring this a to the power n to denominator, it is now a to the power minus n. Now once you take this to denominator, here we have now 1. Right? Yeah. Then what's the law? A to the power n is equal to 1 upon a to the power minus n. That means when we bring this power from numerator to denominator, the sign of the power gets opposite. Other way around, we can consider from the right hand side, when you consider people, a to the power minus n is at the denominator. That you can bring to numerator, then the left hand side, the thing we get, there also the sign gets opposite. Here it is minus, no, it becomes plus. That says people, when we exchange a certain power between numerator and denominator, the sign of the power changes to opposite. Understood? So that's what this result. Okay. Then shall we write down that? Okay. Right. A to the power n is equal to 1 upon a to the power minus n. Right? This is that result. Right. We'll verify this too. Right. I'm going to start this time from this right hand side. 1 upon a to the power minus n. I'm going to start from the right hand side. 1 upon a to the power minus n. Right? This 1, people, I can write as a to the power 0. Why? We proved a to the power 0 equals 1. But there, you have to be very careful. We must write a not equal 0. Yeah, this one I can write a to the power 0. Meantime, you have to mention this a not equal to 0. Why? If a becomes 0, people, 0 to the power 0, we get that is meaningless, undefined, then the statement is meaningless. Thereafter, we can't accept the statement, right? Yeah. Right. So then here a to the power minus n. Then 1 upon a to the power minus n in the left hand side. People, now to the right. To the right. To the right, here we have base A, here we have base A. The numbers being divided. Then you can apply second index law to simplify this. How to simplify this? Writing the same base here, A. Now we subtract this denominator power from numerator. 0 minus n. 0 minus n. 0 minus n, you know, when you remove the bracket minus plus, we get a to the power n. A to the power n. Right? Then 1 upon a to the power minus n. 1 upon a to the power minus n is equal to a to the power n. Understood? The left hand side is equal to right hand side, means what? Right equals to left. Understood? Yeah. So then we get the result. Then a to the power n is equal to 1 upon a to the power minus n. This is how people we simply prove that result. So people, this is the end of the index loss part. Index loss part. I know, very simple things, right? Okay. Now, the next part is people the logarithm part. The most important part, the index also very important, but people that you know already. So we did something which we knew and we justified or verified that the truth of them so far. The laws are important for the next part. The next important part, they are for the logarithms. The logarithms, people, Usually in your first term test, definitely questions come in with certain proofs, and that logarithm lesson really people, we go more deeper than we did in our OLs. Understood? And that knowledge very helpful to work out questions in other lessons in combined math syllabus. Especially this logarithm knowledge we need people, pure maths under integration, differentiation, series, and some occasions in complex numbers, right? So that logarithm lesson important. In logarithm lesson, you have learned really only 3 laws, but in ALs, of course, we learn like 8 laws. Okay, then people, today we start that too. Okay, right? Today we'll start the logarithm also, right? Then next day we can discuss the questions in the tooth, right? Okay, another people, people now will write the logarithms, the heading. Logarithms. Right. Now, people now, suppose, you know, when I write this 100, this 100, you know, we can write this 100 dash 10 squared. 10 squared. 10 squared means 10 into 10, no? 10 into 10 is 100. Okay. Right. So now this 100 has been expressed as a power of a number, as an index of a number, in other words. Then this form of expressing this 100 is called as index form. Index form of 100. Index form of 100. Index form of 100. Right? People, now this index form we convert to logarithmic form. The logarithmic form is, people, this. We write this logarithm, but we don't write, people, the whole word. We only write log in the left-hand side. And this 100 left-hand side number we write here. And the right-hand side, this base, we bring as the base of this log, and we write it here. This is called as the base of the log. This is called as the number of the log. Then its answer, people, we write on the right-hand side this power. Okay, this power. Then this is read as how? Logarithm of 100 to the base 10. Logarithm of 100 to the base 10 is equal to 2. What is the meaning? When you write this 100 as the power of this 10, the required power is 2. That's what it means. So therefore, people, this is called as the logarithmic form of 100. Logarithmic form of 100. Logarithmic form of 100. Understand? Right? So therefore, now you know an index form, how to convert to logarithmic form. Right? Here, index form, we write log, the number we write in the left, right-hand side base, I bring as the base of this log. Now it's also going to be the right-hand side, the power or the exponent or the index. That's how we convert the index form to logarithmic form. Let's see the other way around. Using the logarithmic form, how to take the index form. People, that occasion, what you need to do is ignore this log term, erase this log term. Write this number, here it is in the left. And the base of this log, we bring to right, and we keep the right-hand side number on the head of 10, on the head of that base, like this. We take this 10, we take this 10 to right, and on its head, we put this 2 as a power. So that is how we convert, people, the logarithmic form to index form. Understood? Right. Now, people, in writing logarithms, there are some rules. In writing logarithms, people always, the number available here should be positive. And this base available in the log should be positive value, which is not equal to 1. Right? That means when we write a certain log expression, people, all right, there's certain conditions, subject to certain conditions only we can write. For instance, suppose here log m to the base a. People, there, this m should be a positive value. And this a should also be positive value. And this a should not be equal to 1 because 1 is positive value. But a should not be equal to 1. Subject to those conditions only, people, we can write for the logarithms. Understood? The logarithms, right? People, in your oils, have you ever seen writing something like this? Logarithm of minus 200 to the base 10? No. No. Have you seen something like this? Log minus 10 power, here 300, minus 10 base, 300? No. The base of logarithm cannot be negative. It should always be positive, which is not equal to 1. Understood? So they are the conditions or the rules we have to follow in writing log. People will take down the brief note regarding this, right? Okay. All right. So then under these logarithms, we'll write a brief note. Right. Write down like this. We'll write this. Let capital N equals e to the power x. Okay. Let capital N equals e to the power x. Where n greater than 0. People, what is meant by greater than 0? On the number line, 0 is here. Greater than 0 means numbers which are greater than this 0. They should be on the right of this 0. All the numbers on the right of 0 are positive. So therefore, n greater than 0 means n is positive. N is positive. N is positive. Okay. And a positive such that a not equal to 1. And then here also a positive. A is positive. Then people, n equals e to the power x is called as what? Index form of n. Index form of n. Then we convert this to logarithmic form. Can be written as logarithmic form as log n to the base a equals x, like this. This way we can convert this to logarithmic form. Right now, so therefore, when you write logarithms, people, this number should always be positive. This n here, this number can be 1, but the base cannot be 1. base should always be positive value, which is not equal to 1. Okay, so for negative numbers, logarithms cannot be defined. We don't write logarithms for negative numbers. Understood? Okay, right.